Hey everybody, this is Mr. Ainsworth, and we're going to get into a new lesson here in Chapter 6 in Math 90 and talk about how to add and subtract polynomials. But before we do, we need to get down and talk about some terminology and definitions and, talk polynomial talk. So let's do that. Let's get right into it here. All right, I see a little typo here, so we got to fix it. This is polynomial, P-O-L-Y. Okay, poly means many, first of all. All right, and so the word polynomial can be broken down into two parts. Poly means many. All right, and then nomial, all right, the second syllable of the word right there means term in mathematics. All right, so when you say polynomial, you're talking about something with many terms, whether it has one, two, three, four, five terms, or an infinite amount of terms. There are many different type of polynomials, and each one can be classified two different ways. You can classify it by its degree and by how many terms it has. So we're going to talk about both. All right, so let's first talk about the degree. And the degree is simple. It is the highest exponent of all the terms. So let's write that down. It's the highest exponent, all right, of all the terms. So key concept here, of all the terms. All right, so what you want to do is you want to analyze the exponents right there to determine what is called the degree. All right, and then we'll classify it a different way. We'll classify it by how many terms it has, okay? So a polynomial, classified by its degree. Got to look at the exponents here. So let's look at it. See, so x squared, right? X to the power of 2. This is called the degree, all right, or the exponent of the term. So x squared, or x to the second power, is a second degree term, minus 6x to the first power, so it's first degree. This is a first degree term, minus 7. It's called a constant, all right? And a constant is a 0 degree. We'll talk about that here more in a minute here, but when you compare x squared minus 6x to the first power minus 7, the highest exponent is 2, all right? And so it is a second degree function. So it's degree 2, all right, or second degree. It is the highest one looking at all the different exponents. So the name of the polynomial using that degree, we call all second degree polynomials, all right, quadratics. All right, quadratics. So quadratics, all right, second degree functions. All right. Now I know that some of you guys are familiar with quads. You think 4, but then quad actually means 2 in mathematics right here. All right. In this sense. All right. So quadratics are second degree functions. In this case, it has 1, 2, 3 terms. All right, that are being added or subtracted here. All right, and it has 3 terms, and because of that, we call it a trinomial. All right. Remember, nomial means term. Tri means 3, so we call this a trinomial. All right. It's as simple as that. So the highest exponent is 2, so we call it degree 2. You call any degree 2 polynomial quadratic. It has 1, 2, 3 terms. So you call it a trinomial. Again, tri means 3. Nomial means term, so 3 terms. Now, the second one here, 3x minus 1, well, it's 3x to the first power. All right, so it's a first degree function, first degree. We call that a linear function. All right, we studied those all for a semester. All right, we solved first degree equations. We even graphed first degree functions, all right, called linear functions. So if the exponent here is, the highest exponent is 1, you call it first degree or linear. This has 1, 2 terms, all right, it has 2 terms, and we call that a binomial. All right, bi meaning 2, nomial meaning term, so binomial 2 terms. All right, now when you look at this next one here, x to the 4th minus 3x cubed plus x squared minus 5x plus 7. All right, you look at all the exponents, 4th degree, 3rd degree, 2nd degree. And then if you don't see an exponent, guess what? It is 1, so that's 1st degree. And a constant is classified as 0 degree. And you look at the highest exponent, and it is 4, so it's 4th degree. All right, we call that a quartic. Okay, a quartic function. All right, they all have names, but typically people learn names up to the 5th degree, which is quintic, which I don't have up here. All right, and then after that, you just classify it by the degree because it gets too complicated. But 4th degree right here, because the highest exponent is 4, it's called a quartic. It has 1, 2, 3, 4, 5 terms. All right, and when you classify a polynomial that has more than 3 terms, we just call it a polynomial in general. All right, why? Because poly means many, so polynomial. All right, there's a name probably for it here, but we're only going to memorize all the different names up to the 3rd terms, up to 3 terms called a trinomial. Okay, any term that has a single term, like the next one, 9, is a single term. We call it a monomial. All right, mono meaning 1, so monomial. All right, mono meaning 1, bi meaning 2, tri meaning 3, and so on. If it has more than 3, we're just going to call it a polynomial in general, although all of these are polynomials, because the general term for this is poly, meaning many. All right, whether it's 1, 2, 3, 4, 5, or 6 terms, it doesn't matter. They are all polynomials. Now, if it's a constant, all right, you can write 9, believe it or not, is 9x to the 0 power. You have to remember that x to the 0 power equals 1 as long as x is not equal to 0. And that's why a constant is classified as 0 degree. All right, 0 degree there. And in this case, this right here is called a constant term. All right, because it's not a variable, right? Even though I wrote it as 9x to the 0 power, x to the 0 power is classified to be 1. When you just see a number, a numerical value and no variable, you call it a constant. All right, so all constants are degree 0. And this happens to be a single term called a monomial. The next one here, if you look at the exponents, you compare 3 and 2. Well, 3 is higher, right? Okay, so it's 3rd degree. So 3rd degree right here. All right, and that is called a cubic polynomial. All right, cubic. So 2nd degree quadratic, 1st degree linear. All right, 4th degree quartic, 3rd degree cubic. And it has 2 terms, 1, 2. All right, it's 2 terms, and we call that a binomial. All right, just like the previous one in 3x minus 1. So it's called a binomial. So just give you some examples here, getting used to the lingo, right? The terminology and the definitions. All right, now when it comes to polynomials, there's something called standard form that we all want to go by because it's the way to write polynomials in a very simple manner so we can all get used to it, okay? And standard form for a polynomial means that the degrees of the monomials, okay, monomial meaning single terms right here, are in descending order, all right, from high to low. So it means that the degrees of the monomials are in, all right, what's called descending. Okay, that means going down. Descending order. All right, let me just put in common words. Going down. All right, from high to low. All right, let's put that in red. All right, high to low. All right, this is a good example. 3x cubed minus 5x squared is a polynomial standard form because it is in descending order from high to low. And likewise, the first one here too. So when I write something like x squared minus x plus 2, notice that it goes 2nd degree, 1st degree, 0 degree. All right, and this is just a very simple example of something that's written what's called descending order, which all polynomial results should be written in. All right, it's just a standard thing that we all do when we write the results. Okay, so the first thing you want to do is just get used to what's called standard form. Again, high to low. That's all you have to remember. So when you take a look at the results, all right, this first polynomial here, you got 13y squared minus 5y to the 4th plus 3y. You got 2nd degree here, you got 4th degree, and then when you don't see the exponent, it is 1 right here, guys. All right, when you compare those exponents, you want to write them in descending order, high to low. All right, it's called standard form. All right, so here we go. We're going to write the 4th degree term first, and then the 2nd degree, and then the 1st degree, keeping track of the coefficients. Now, this is minus 5y to the 4th, so it's negative. So we're going to start off with minus 5y to the 4th. All right. 13y squared is positive, so we're going to go plus 13y squared, and then plus 3y. All right. And notice the exponents. Let me highlight them. 4th degree, 2nd degree, 3rd degree. That is called high to low, descending order, or what's called standard form. Okay. And we just need to get used to it. All right. Now remember, constants are 0 degree. So you write all constants last. This goes last, the constant. Okay, always write that last. All right, it's 0 degree. So you take a look at the third degree term, the minus 5y cubed. So you go minus 5, x cubed. All right, and then minus 13x squared, so minus 13x squared. All right, and then the 10 is positive, so you go plus 10. Because if you look in front of the number here, it is positive. It's not negative. It's not being added or it's not being subtracted. And you don't see a negative sign either. So it's a positive number, so you go plus 10. And then notice the degrees. Third degree, second degree, and then the constant, like I said earlier, is 0 degree. It's that simple. All right. So let's try it again one more time. So on this one here, we got negative 8p plus 13p to the fifth power. Look at fifth degree right there. That's quintic, all right, and then plus 2p cubed, all right, or to the third power. So you start with the highest degree right here, degree 5. So 13p to the fifth, all right, plus 2p cubed, all right, minus 8p because it is negative, minus 8p. Now notice the exponents, fifth degree, third degree, and if you don't see it, all right, it's first degree. I'll just put a 1 there just for reference. All right, and go high to low. And that's the key idea of standard form. Just get used to it. Write all your results in respect to that way, okay? So in the next few examples here, what we're going to do is we're going to simplify with regrouping, and we're going to write the results in what's called standard form. All right, now the reason why you want to regroup here, which is important, is because you want to regroup like terms. Okay, always regroup like terms. So let's write down the steps first. Regroup like terms first. All right, and then step 2, simplify. All right, the groups. All right, so here we go. Now, from again, high to low. So the highest degree I see is second degree. So I see a 7x squared minus 2x squared. That's my first group. So 7x squared minus 2x squared. Look what's going on in front of the term. Are you adding it or are you subtracting it? In this case, we're subtracting the 2x squared. Then I see some first degree terms. I see a minus 8x and a plus 9x. So let's put that in the second group. So minus 8x plus 9x. And then the third group here, I see a constant 1. All right, so that's our last term right there. And it's being added. Notice it's a 1 plus or a plus 1. So I'm just going to go plus 1. All right, and then you simplify. Step 2, you simplify. 7x squared minus 2x squared gives you 5x squareds. All right. Second group here, a minus 8x plus 9x is the same thing as 9x minus 8x right here, which is obviously 1x or x. And then you got this plus 1. And that's commonly written as 5x squared plus x plus 1. All right, you don't need the 1 in front of the variable because 1x is the same as x. All right. So what you want to do is you want to regroup like terms and then simplify each group. All right, all you do is combine the coefficients. If you start off with 7x squareds and take away 2x squareds, you have 5x squareds remaining. It's that simple. And 9x's, take away 8x's, is 1x or x. And that is how it's done, my friends. And by the way, it's in standard form, right? Why is that? Well, let's write down high to low again, okay? So high exponent to low, high to low. Second degree, first degree, and then 0 degree, which is the constant. Okay, so looking at this long polynomial right here, I see some third degree terms, some second degree terms, some first degree terms. So you start off with the third degree terms first, the highest degrees. So let's start off with that, regroup them. So minus 3x cubed minus 4x cubed. All right, next group, I see some x squared terms, so second degree terms. All right, let's focus in on those. So it's plus 8x squared, and then a minus 2x squared. And then I see some first degree terms, plus 8x plus 3x. So let's focus in on those for a little bit. So plus 8x plus 3x. And then what you want to do is simplify the groups, right? Just like I said earlier. So a minus 3x cubed and a minus 4x cubed is a minus 7. Why? A negative 3 and a negative 4 is a negative 7, x cubed. Next group. We have 8x squared minus 2x squared. Well, it sounds like a positive 6x squared remaining, right? 8 take away 2 is 6, x squared. And then last group here, we have 8 plus 3 is 11, so plus 11x. Okay? If you have 8 x's and then you have 3 more x's, then you have 11 x's total. And then this is in standard form because of your exponents are in descending order. Third degree, second degree, first degree. And remember, if you don't see the exponent, it's always 1. So you got descending order here, high to low. Third degree, second degree, first degree. So you want to regroup and simplify and develop good habits. And you do that, you're going to be doing all right. Okay? Now, it obviously gets a little bit more than that, more intense than that, because in mathematics, you're building up skills, right? So in this case, in all these right here, we're going to be bringing in what's called distributive property. We're going to continue to regroup like terms with the same degree. That's important, which is what I just did. We're going to simplify the groups with the same degree, and then we're going to write it in standard form, which is from high to low. All right, so we're going to show the distributive property. We're going to show the regrouping. Okay, we're not going to skip steps. All right, so we got 13x here plus 12x squared. All right, and then you got it minus 2 times this group. So what you need to do is focus in on this right here. You got to distribute the negative 2 and you got to distribute it twice. You got to multiply negative 2 times 5x and you got to multiply the negative 2 times 13x squared. So negative 2 times 5x is a negative 10x. Negative 2 times 13x squared is a minus 26x squared. So you want to distribute. All right, distribute first. All right, step 2, regroup. Okay, so let's do that. Let me see, I see second degree terms, so I'm going to start off with those. 12x squared. I see a minus 26x squared here. I'm looking right here, plus 12x squared and then a minus 26x squared. Okay, that's my first group. My next group here, I got my linear terms. Let's see here. I got 13x and then a minus 10x. So plus 13x minus 10x. Those are my first degree terms, okay? So then you want to simplify, all right, the groups just like I did earlier. And 12 minus 26 is a negative 14. Small minus big is always negative. So minus 14x squared. And then the second group here, a little bit more simple. 13 minus 10 is 3, so you got 3x's remaining. Because 13x's minus 10x's only gives you 3x's remaining. All right, so you want to distribute first. Step 2 right here, and this step here I regrouped. Okay, so step 1 I distribute, step 2 I regroup, and step 3 what I did down here is I simplified right here, and it's already in standard form, so we're all good. We're done at that point. And you can't combine these because you got a second degree and a first degree. Well, guess what? You can only combine terms with the same degree, so they're not like, okay, unlike terms right here. Okay, unlike terms because the terms, they're different degrees. All right, so you can't go any further. All right, because we're adding, we're not multiplying. It's totally different. All right. Now, if you want, you could make this video interactive if you like. Okay, you could pause and play the video if you like, if you think you know what you're doing here. Especially if you're working on your own, you can do a little pause and play action. All right, you can pause the video, work it through, and then press play and check your work if you like. All right, or if you still need a few examples, you can listen to a few more before you start doing that. But the idea is the same for all of these. Okay, you want to distribute first, regroup, and simplify. Okay, those 3 steps. All right, so here we go. We're going to distribute the 4 twice. All right, and then we got to distribute again here. We got to distribute the minus 2. All right, we got to do a lot of distributing. So here we go. Let's start off with this 4 here. 4 times 3x squared is 12x squared. 4 times 12x is 48x. Okay. Now distributing the 2, a minus 2 that is. Negative 2 times 5x squared is a minus 10x squared. And a minus 2 times 7x is a minus 14x. So I distribute into both binomials. All right. Next step, we want to regroup like terms, the second degree. So I'm going to regroup. So I got 12x squared here, my second degrees. I got a minus 10x here, 10x squared. And this first group right here. And then my second group is here. I got plus 48x, all right, and a minus 14x. And you're only allowed to combine terms with the same degree. So that's why we regroup, okay? And then when you simplify, 12 minus 10 is usually 2, so you get 2x squared here. 48 minus 14 is usually 34, so we get plus 34x's here. And notice that they're in descending order. If you look at the exponents, this is a second degree term, and that's a first degree term. It's in descending order, high to low. So you're good to go. Okay, so distribute, regroup, and then simplify, and you could develop really good habits and make this easy. Okay, and like I said, if you want to pause and play, it's a really good thing to do. All right, pause and play on the video. So pause the video and go for it. And then when you're ready, press play and check your work. Here we go. All right, we're going to distribute through the 3. So 3 times 3y is 9y. 3 times 12y squared is 36y squared. Step 2, we got to distribute through the minus sign. So minus 5y and a minus, all right, 13y squared. You can think of it as a negative times a positive. Negative times a positive 13y is a negative 13y squared. So you got to distribute twice. Regroup, as I was saying. So starting with your second degree terms, because that's the highest degree. So 36y squared minus the 13y squared. And then your next group is a 9y, it's positive, minus 5y. Okay, you can only combine terms with the same degree. 36 minus 13 is 23, so we have 23y squared. 9 minus 5 is 4, so we have 4y here. And again, it's in descending order, second degree, then first degree. And that's all there is to it, my friends. All right. Now you give it a shot. You gotta take 3 minus 5y plus 2 times all of this. So you got to distribute on this one. You got to distribute the 2 3 times because we have a trinomial. All right, so you have to do that. So you got to take 3 minus 5y plus, let me see, 2 times 4 is usually 8. 2 times negative 5y is minus 10y. And then 2 times 2y squared is a 4y squared. And then you have to regroup like terms, starting with the highest exponent. And there's only one second degree term, so we're going to start off with the 4y squared, and then minus 5y. Take a look at the variables here, minus 5y, and there's a minus 10y. And then there's a plus 3 because it's positive, and a plus 8. So here we go. There's nothing to combine with the 4y squared because that's the only second degree term. But there's 2 first degree terms. There's a minus 5y and a minus 10y is a minus 15y. If you subtract 5 and you subtract 10, you're subtracting 15 in all. 3 plus 11, excuse me, that's the answer. 3 plus 8 is 11. All right, and so you have your answer in descending order too. All right, second degree, first degree, and then the constant 11, that's 0 degree. All right. And you guys, it just takes practice. It just takes, seriously, just practice to get good. All right, so pause the video. All right, give this one a shot. All right, go. All right, I'm going to assume that you are done. So we're going to distribute the negative 5 here. So negative 5 times 3x cubed is negative 15x cubed. Negative 5 times 12x squared is a negative 60 x squared. And then negative 5 times negative 5x is a positive 25x. And then I got this plus 13x cubed here. Okay, so I want to regroup the like terms. So I see 2 third degree terms. I see this term here and this term here. They're both third degree terms. So I got a negative 15 x cubed. I got a plus 13 x cubed. That's my first group. I got this minus 60 x squared here, and I got a plus 25x. Nothing to combine with them or group up with them. Combining my third degree terms, negative 15 plus 13 is negative 2. So negative 2x cubed minus 60x squared plus 25x. And notice that it is already in descending order. Look at the exponents, third degree, second degree, first degree. Okay, all right. And then let's get some more practice here. Uh, All right, so here we go. Let's give it a shot. We got to take 13y plus 9 minus 12y squared plus 2 times all of this. So it looks like the 2 here we got to distribute 3 times. Why? Because we have a trinomial there. So you have 13y, all right, plus 9 minus 12y squared, plus 2 times 5y is 10y. 2 times 13y squared is 26y squared, and then 2 times 7 is 14. Now let's group up like terms, okay? I see a minus 12y squared and a 26y squared. Those are the highest degrees. So we're going to start off with those. So minus 12y squared plus 26y squared. And then I look for my first degree terms. I see 13y and 10y. So let's group those up. So plus 13y plus 10y. And then my last group here is the 9 and the 14, so plus 9 plus 14. Okay. So what do we have in the first group? Negative 12 and 26, or 26 minus 12 is 14, so 14y squared. Notice how I thought about that too, by the way. Negative 12 plus 26 is 26 minus 12, or 14. So I have 14y squared there. My next group, this group right here, 13 plus 10 is 23, so I have plus 23y here. And then my last group here, 9 and 14 is 23. And notice that the exponents are from high to low, right? So second degree, first degree, and the constant 23, that's 0 degree. All right? And that is how you do it, my friends. All right? The only other thing in this lesson that you got to get good at is, it's evaluating polynomials at specific points. Okay. All right, let me show you how it's done here so you guys can try this too. All right, so we've got a second degree. Look at this. We got a second degree quadratic. All right, so it's a second degree quadratic. Remember, second degree means quadratic. And it's degree 2, obviously, because the highest degree is 2. All right, and we want to find the value of the function at particular points. Now, we say p of negative 1. That's how you say this, okay? So we say p of x is equal to x squared plus 7 times x minus 3. All right, this is called function notation. Function notation. All right, and it's just a fancy way of saying, hey, take this polynomial and evaluate it at x equals negative 1. All right, so all you do is take whatever x is and you substitute it into the function wherever you see the variable, okay? So I got to take x, whatever x is, and square it, plus 7 times x minus 3, where x in this case is negative 1. So let's do that, all right? So I got to take negative 1 squared. Notice the parentheses there. They're important. You got to include them. All right, plus 7 times the negative 1, all right, minus 3. And you got to follow the order of operations. And when I say that, I'm talking about PEMDAS or, whatever you learned back in the day when it comes to order of operations. Now, you always evaluate the exponents first. All right, negative 1 squared means negative 1 times negative 1, which is positive 1, plus 7 times negative 1 is negative 7, and then minus 3. From left to right, we got this right here. 1 plus negative 7 is negative 6. Minus 3 more is a negative 9, right? All right, why is that? Well, negative 6 minus 3 is the same thing as negative 6 plus a negative 3, and a negative plus a negative is a bigger negative, all right? So the function evaluated x equals negative 1 equals negative 9, okay? So all I did was substitute a number into the polynomial and evaluated it. That's why we say evaluating. That's all I'm doing. Okay, you evaluated many linear functions, and now you evaluate higher degree functions like second degrees and so on. All right, so let me show you again. It doesn't matter what x is. In this case, x is -2. You got to take x and square it plus 7 times x minus 3. So it's going to be -2 squared plus 7 times -2 plus 3. And then evaluate it. -2 squared is -2 times -2, all right, which is 4. 7 times -2 is -14, all right, and then you have to add 3. You can add the numbers, the positive values too first if you want. So 4 plus 3 is 7, all right, and then you have to add -14. So you could do it this way if you like, all right. 7 plus -14 is -7. Or you could do it this way. You can go left to right. 4 plus -14 is -10, and then -10 plus 3 is still -7. So if you don't want to go left to right, you don't have to. If you want to combine the positive numbers first, it's totally up to you, as long as you do it all correctly. Okay. And the last one here, x is 4, so find p of 4. Okay, we say p of 4, not p times 4. All right, we got to take x and square it, so 4 squared. All right, plus 7 times 4. Just look at the function up here, this one. All right, and 7 times 4. All right, and then add 3. Figure out what that is. 4 times 4 is 16. 7 times 4 is 28, and then we have to add 3. 16 and 28. If you don't know what that is, go ahead and line them up if you want. Okay, add the two together, and you get 14. 30 and 14 is 44. So this is 44 plus 3, which is 47. All right, so when you evaluate a polynomial, I don't care what the degree is, it's just straight substitution. All right, using the notation called function notation. All right, that's what this is right here. All right, we say p of -1 or p of -2 or p of 4. It just means take your value of x and substitute it into the function. All right. Now on this next one here, we have a cubic polynomial. Okay, it's third degree. All right, it's called a cubic polynomial. It's third degree. And you want to evaluate the polynomial at x equals 1, and then at x equals 2, and then at x equals -3. All right, so I'll show the first one here, and then you guys can try another one, okay? So when you find p of 1, you substitute 1 into the polynomial wherever you see x. So this is 3 times 1 cubed minus 4 times 1 squared. Just follow the polynomial. Minus 10 times 1 minus 1. So notice that I substituted 1 in wherever I saw x in the polynomial. Okay? Got to go slow in that step right there too, by the way. And when you evaluate a polynomial, you always evaluate the exponents first and then multiply. All right? Exponents first. All right, then multiply. Okay, what do I mean? Well, I'm talking about this part right here. So you don't want to go 3 times 1 in the cube. That's not following the order of operations. That's the most common mistake people make. You got to take 1 cubed first. You always evaluate the exponents first. So this is 3 times 1 minus 4 times 1 minus 10 minus 1. 1 cubed is 1 times 1 times 1, which is 1. 1 squared is 1 times 1, or 1. That's why I said that. And then you multiply now. So this is 3, and this is 4, and then minus 10 minus 1. And then you go from left to right if you want. 3 minus 4 is -1. -1 minus 10 is -11. Minus 1 more is -12. So the polynomial evaluated at 1 equals -12 in this case. And all you do is get some practice. I mean, you substitute your number into the polynomial and evaluate. That's what you do, okay? And remember my little side note here. This is a really important one, especially when it comes to polynomials with higher degrees. You better evaluate the exponents first, then multiply. Otherwise, you're going to get answers that don't make any sense. All right, so here we go. We're going to take 3 times now 2 squared. Excuse me, cubed. Let me rewrite that. Got to look at the polynomials. 3x cubed minus 4 times x cubed. So minus 4 times x squared minus 10 times the value. So minus 10 times x, which is 2 in this case, and then minus 1. So we have 3 times, let me see, 2 cubed. Let's do a little side work over here. 2 cubed, that's 8, right? 2 cubed means 2 times 2 times 2, which is 8. Okay, so this is 3 times 8 minus 4 times 4. 2 squared is usually 4, minus 20 minus 1. Well, I see 24 here, minus 16 here, minus 20 minus 1. Then you got to go left to right. 24 minus 16 is 8, so these two give you 8, minus 20 minus 1, and then I get a negative 12 here, minus 1. 8 minus 20 is negative 12, which gives you a negative 13. So you got to do a little side work perhaps. You have to go left to right, and you have to, let me write that down, left to right. All right, and then, all right, you're going to get some good results. All right, as long as you go slow and back to basics. All right, now let's pause the video, try this one here. Okay, I demonstrated twice. Now you try it. All right, let's check your work. So it's got a negative, we got 3 times whatever x is squared. So we got 3 times negative 3 cubed, excuse me. Got to go slow, like I said, minus 4x squared. So minus 4 times negative 3 squared, minus 10 times x, which is negative 3, and then minus 1. Let's do a little side work here. Let's take negative 3 and cube it. Well, that means negative 3 times negative 3 times negative 3. Well, that means 9 times negative 3, or negative 27. So right here I get 3 times negative 27. Here I got negative 3 squared, which is 9, so I got to take 4 times 9. Here I get a negative 10 times 3, which is 30. Do that in your head. And then minus 1. So notice how I'm doing steps at a time. I'm working on the exponents first, now I'm multiplying. I got to take 3 times negative 27, which is going to be negative something. Okay, so what would it be? So let's take 27 times 3. Sorry. I don't know why it's doing that. So that's 60 and 21, 81. So we get a negative. Okay, so let me switch it here. I'm sorry. So right here we get negative 81, all right, minus 36. 4 times 9 is 36, plus 30 minus 1. Okay, so 81, negative 81 minus 36, you got to add these. So 81 and 36, all right, that's 117, but it's got to be negative. So I get right here, I get negative, I'm talking about this portion right here. This is negative 117. Let me write that down here. So negative 117, and then 30 minus 1 is 29, so I got to add 29, which is going to be a negative result. And you got to subtract these. So what is that? So I don't know. Do you guys like to line them up? I don't know. What do you guys like to do? So subtract, you got borrow. All right, 10 minus 2 is 8, so maybe negative 88. Okay, so the final result is negative 88. All right, and then again, look at what we're doing here. I started off with a quadratic, so I start with a second degree polynomial. All right, and then the next few examples, cubic polynomial. All right, and then what are the next few examples? A quartic, all right, fourth degree function. Okay, this is a quartic polynomial. Fourth degrees are called, they have a cool name, quartics. Everybody say quartic. All right, fourth degree. All right, let's give it a shot. Okay, let's substitute 1 in, all right? So I got to take 1 to the 4th plus 2 times 1 to the 3rd power minus 3 times 1 squared minus 4 times 1 minus 1. You got to substitute 1 in everywhere you see x right there, and then simplify. Remember, exponents first. Exponents first, all right, then multiply. I wrote it down before, but I'm going to write it down again because that is the most common mistake I see people make is they don't do this. All right, 1 to the 4th is 1 plus 2 times 1 minus 3 times 1 minus 4 minus 1. All right, so what do we get? We get 1 plus 2 minus 3 minus 4 minus 1. So 1 plus 2 is 3, minus 3 is 0. So all of these right here, this right here is 0. And then a minus 4 minus 1, well, that just gives you a negative 5. So the answer is negative 5. There you go. And then you got to try it for p of negative 2. All right. Again, these are just x values, right? You just set or substitute the value in and see what you get. That's all you do. It's a substitution thing. So let's take negative 2 raised to the fourth. So negative 2 raised to the fourth, and notice you use the parentheses there, plus 2 times negative 2 to the third, minus 3 times negative 2 to the second power, or squared, minus 4 times negative 2, and then minus 1. Let's see what we get. Let's do a little side work too, by the way. Negative 2 to the fourth power. Negative 2 times negative 2 times negative 2 times negative 2. Well, that's 4 times 4. That's 16. So this is equal to 16 here, plus 2 times, let me see, if you multiply 3 negative 2's together, you get 4 times negative 2, or negative 8. So you see how we do the little side work here? You get good results. All right, minus 3 times 4. All right, plus 8. Negative times a negative is positive, minus 1. So I got 16 here, plus a negative 16. That's going to cancel out. Minus 12 plus 8 minus 1. So this portion right here is 0. Negative 8 plus, well, this portion's 7. Negative 12 plus 7, well, that's a negative 5. Holy cow, I got negative 5 again. That's funny. Okay, that doesn't usually happen. All right, we got kind of, that's coincidental, guys, okay? So the results are the same, but, it's coincidental. All right, and then what do we get for the last one? Why don't you pause the video right now and give it a shot? All right, let's check your work. So P of 3, here we go. So we got to take 3 to the fourth power, plus 2 times 3 to the third power, minus 3 times 3 squared, minus 4 times 3, minus 1. Okay, so here we go. 3 to the fourth. So 3 to the fourth equals 3 times 3 times 3 times 3. Usually for most people, grouping would make it easier, and you get 9 times 9, or 81. So this is 81 here, plus 2 times something, minus 3 times something, minus 12, minus 1. So 3 cubed is 3 times 3 times 3, which is 27. 3 squared is 9. So we got to multiply 2 times 27. So 2 times 27, all right, 54. So 81 plus 54, all right, minus 27, minus 12, minus 1. So what's that? Let me see. 80 and 50 is 130, so this is 135, this portion right here. A minus 27 and a minus 12 is a minus 39, so this portion is a minus 39. Minus 1, that's going to be a minus 40. So this is 135 minus 40, all right, and that should be 95. Excuse me. Yeah, that's right. 135 minus 40 is 95. So the last result should be 95. Hopefully I did it right. I haven't checked my work, but it looks pretty good. All right. Hopefully that's all looking good. All right. So you just take some practice. That's all it does. So you got to go back here and go back to the beginning and get good to the with the terminology, so the lingo, because you got to know the lingo in order to understand things in mathematics and in any subject. All right, and then when it comes to standard form, that takes a little bit of practice. Easy concept, high to low in respect to the exponents. And then when it comes to simplifying, you distribute a little bit, regroup like terms with the same degree. That's important. All right, simplify the groups and express your answer from high to low. All right, standard form. All right, you guys, that is my lesson here in the third lesson in chapter 6 here in Math 90. And I will see you guys in my next lesson later. This is Mr. Ainsworth. I'm out of here. Bye-bye.